Hi, I'm Jim Dick from Emerson. Welcome to Vilter single screw training. We're doing a little overview on the single screw compressors. I've got a 240 millimeter machine here and a 205 millimeter machine. This is called our VSS compressor. This is a VSM compressor. We've got discharge and suction ports on it. So we've got the suction gas coming in the top on this compressor and discharging out the end of the discharge manifold. There'll be a 90 on here, which turns down into the oil separator. On the VSM compressor, it will be down discharging directly out of the discharge manifold. The direction of change is already in the compressor. Suction gas will be coming in one of the side ports here, so the cover won't be there. That's what makes these compressors a little bit different looking on the separator. We've got the command shafts here, and that term is used for our capacity and volume control on the compressor. So all screw compressors need a way to control the volume of the gas. We also have ports on the compressor on the top and on the bottom for oil injection, for economizing or liquid injection, depending on your application. These compressors are called open drive compressors. They will be driven by an external motor with a coupling in between. On the VSM compressor, we have a straight shaft and a shaft seal here. On the VSS compressor, this particular one has a tapered shaft, but again, that will be dependent on the application. So there might be tapered or straight shaft compressors. These compressors were used for ammonia, but they can be used for other natural refrigerants like CO2 and propane, as well as synthetic refrigerants, all kinds of different ones that we have out there now. Also, they are used in the natural gas and methane production and gas boosting applications. So the compressors are used for many different things. Let's get into the system components now. Hi, welcome back to the Vilter single screw. Again, we're going to look at this 240 millimeter machine now, and we're going to spend a lot more time with this compressor. We're going to be taking it apart. And so I'll just review. We've got the suction gas coming in here. We've got the discharge gas going out the discharge manifold here. There will be a 90 here going into the oil separator. We've got the command shafts here and a volume slide on the bottom here and a capacity on the top. Again, we have to do that with a screw compressor to adjust the gas flows through the machine. We have ports on the top for oil injection or economizing or liquid injection. Again, the application will be specific for your site. Okay. Now, we want to do let's say a maintenance inspection on this compressor. So we're going to check the wear of the bearings and different things like that. So we have to do this safely. Remember, one thing we're going to need to do are lockout, tagout. So we have to lock out all sources of energy. Okay, so electrical as well as any sources of energy, which is refrigerant or gases or whatever that you have in this system. Okay, so you're going to have to do that based on your local codes. We're going to have to close off our suction line. We're going to have to close off the discharge of the oil separator. There's no valve here to close off. So we're going to have this whole oil separator and oil system that's going to be full of refrigerant. So you're going to have to recover that. Now, your plant may be different. You may be able to use other machines to pump the refrigerant out of this system into the larger system. Or you may be able to just isolate it and recover the refrigerant using standard practices that you have for your area. But remember, you have to remove the energy, remove the refrigerant that's in it. Now, this compressor was running until you arrived. So there's going to be a lot of oil in this compressor when you shut it down. So when it shuts down, it'll probably be half full of oil almost. Now, do you really want to collect all that oil when you take it apart? You may want to say, you might have the luxury in saying, I'm going to do this inspection tomorrow. The operator of the plant may say, I'll shut it down for you on the evening shift and let this thing sit for a few hours, cool down, and let the oil drain out of the compressor into the oil separator, which gives you a lot less oil that you have to take out. Because once I remove this cover on the side, which allows us to look at the internal gate rotor blades and internal parts, we have to collect that oil. So whether there's this much oil in it or this much oil in it, it's going to be, makes a lot less work for you as well. So that's one of the things to remember when you're preparing for an inspection. The other thing we're going to do is we're going to check the wear of the main bearings. And we want to see, is there any movement in the main rotor? Are the bearings, is there thrust movement, and is there radial movement? So we're going to measure how much radial meaning side to side movement on this shaft, and axial is in and out. So we want to measure that, and we're going to measure that with dial indicators. Inside the compressor, we have the same measurements. We have radial and axial measurements. We have wear measurements. We have another measurement called shelf clearance. We have a measurement called rotor backlash and blade float. So let's get into those.